All right, so we're going to be talking about solving linear inequalities, all right? So just remember these are linear inequalities, but the key is that they are linear, which means we will be able to follow our 6 steps to solve an equation or an inequality that happens to be linear. So you can go ahead and watch my previous video on solving linear equations to figure out those steps. But what I want to do is just go ahead, we're going to dive right in. So with all these problems, we're always going to be doing the same 3 things. And those 3 things are going to be, we want to solve, we want to graph, and then finally we want to write interval notation, okay? And just to recap real quick, remember our inequality symbols are going to be less than, greater than, less than or equal to, greater than or equal to. And the symbols that we use when we're graphing, so symbols for graphing, will be parentheses for the less than or greater than, brackets for the less than or equal to and greater than or equal to, and then finally, when we go ahead and graph, we always like to just kind of draw a little number line, put 0 right in the middle. If we shade the far left arrow, that means negative infinity. And if we shade the far right arrow, that means positive infinity. And whenever we use negative or positive infinity, so even though these are not inequality symbols, I'm just going to include them down here. So if we use negative infinity or positive infinity, we always use parentheses when we're writing out the interval notation for that. Okay, so let's go ahead. I just want to copy and paste these directions real fast. So let's do that. And we're going to just do a bunch of examples here. Well, not a bunch. We're going to do enough, though. Okay, so the first one I want to look at is going to be 6x is less than 10x plus 19. And since we've already had a lot of experience with this in class, I'm just gonna dive right into this. So I don't see any fractions. I don't see parentheses. There's nothing on the left I can combine, nothing on the right that I can combine. So I need to get the variable terms on one side, constant terms on the opposite side. So what I will do is I will subtract 10x from both sides. That leaves me with negative 4x on the left, which is less than positive 19. Okay? Now from here, I need to be extremely careful because notice my next step is going to be to divide both sides by the number in front of the variable. And when I divide, notice I'm dividing by negative 4. Okay? So let me get out my red pen because I'm going to put a star and say we are dividing by a negative value or negative number. Therefore, and this is huge, we must reverse the inequality symbol. Okay? So when I go ahead and simplify this on the left-hand side, and I'm going to leave it in red, I get x, but now my inequality symbol is going to reverse from less than to greater than. And then on the right-hand side, I get negative 19 over 4. So that's what this is solved. But now let's go ahead. We're going to graph and write the interval notation. So I draw my number line. I put 0 right in the middle. Since our solution is a negative value, I will put it on the left-hand side of 0. Now I know this is greater than, and if you think about this, and if you're looking at the screen right now, notice that this inequality symbol has the same shape as the right end of my number line. So what I'm going to do here is I'm going to use a parenthesis. I'm going to graph or shade everything to the right. Okay? And then from here, I can write my interval notation. I start with a parenthesis, negative 19 over 4, comma, positive infinity, with a parenthesis. Now, an easy way to check ourselves to make sure that our solution is correct, what we're going to do is we can pick a number within the shaded region or a number within our interval, and we're going to substitute it back into the, we're going to substitute it back into the original inequality. So let me write the original inequality first. 6x is less than 10x plus 19. And as a test point or a test value, if I can pick it, I will always pick the number 0 because that's the easiest number for me to algebraically manipulate with. So I get 6 times 0 is less than the 10x times 0 plus 19. On the left-hand side, I get 0. On the right-hand side, 10 times 0 is 0 plus 19 is 19. And then I ask myself this question: is this a true statement? And the answer is yes. So I know not only is my solution correct, put a little smiley face next to my solution, I know my graph is correct, and I know my interval notation is correct. All right? So now let's go ahead. We're going to do another problem here. This one will ramp up the difficulty here a little bit. So we have 8p plus 3 times the quantity, p minus 12, is greater than 7p minus 28. Okay? So from here, we're just going to go ahead and do everything the same that we did prior. So I'm going to first look for fractions. I don't see any. Step 2, look for parentheses. I definitely have that. So I'm going to go ahead and just distribute. That's going to give me 8p plus 3p minus 36, which is greater than 7p minus 28. Now I look for anything on the left-hand side to combine. I can definitely combine the AP plus the 3p. So 8 plus 3 is going to be 11. P minus 36, which is greater than, then I do the same thing on the right. And there's nothing that I can combine on the right. So from here, I'm going to get my variable terms together, constant terms together, and make sure they're on opposite sides of the inequality. So what I'll do is subtract 7p first from both sides. 11 minus 7 is going to be 4p minus 36, which is greater than negative 28. Then I'm going to add 36 to both sides of my equation. Both sides of my inequality to give me 4p is greater than positive 8. And then finally, I will divide both sides by 4 to give me p is greater than 2. So here's my solution. Now I'm going to go ahead and graph. So I put 0 right down the middle, put 2 little dash marks and label 2. Now this is going to be a parenthesis that opens to the right, and I'm going to shade to the right. And then I can go ahead underneath and write my interval notation from 2 to infinity with parentheses around everything. All right? So now we need to look at a situation that we may run into. Okay, so here's another problem. This is going to be 8x minus 2 times the quantity 5 minus x, which is less than 4 times the quantity x plus 9 plus 6x. So if you look at this, it looks like it's a very big problem, but it's really not. Once we start to get moving here, you're going to see that as long as you follow your steps for solving anything linear, you really start to move through these problems pretty quickly. So I do not see any fractions, but I do see parentheses, so I'm going to go ahead and distribute. 8x minus 10 plus 2x, which is less than 4x plus 36 plus 6x. Now, I'm going to look at both sides, and I'm going to say, can I combine anything on the left-hand side? Well, if you look, the 8x and the 2x, I can totally combine those two together. So that's going to give me 10x minus 10, which is less than. Now, over here on the right-hand side, I look here and here, and I can combine them. So that is going to give me 10x plus 36. Okay, so now from here, we're just going to keep moving, but something's going to happen, all right? So we need to get our variable terms on one side, constant terms on the opposite side. So I'm going to go ahead and get my variable terms together. And the one that I'm going to focus on, so everybody knows, is this 10x right here. So what I'm going to do is I'm going to subtract 10x from both sides of my inequality. So minus 10x and minus 10x. And I want you to look at what happens here. When I subtract 10x from both sides, it looks as if my variable ends up canceling itself out. And it does. And that's okay. That'll happen. But then the question becomes, how do we interpret that? So I want us to really focus on this right here. I want us to look at this statement. And I want us to ask ourselves, is this a true statement? And when you think about it, is negative 10 less than 36? And the answer is yes. So because we can say yes to this very last part in our problem, what we will say is our solution, let me write it like that first. Our solution will be all real numbers. Okay? Our solution is going to be all real numbers. Now let me explain what's happening here. What this is saying here in red, our solution will be all real numbers. What that is saying is no matter what value of x that you choose to substitute in for the variable, the left-hand side of our inequality will always be less than the right-hand side, okay? That will always happen with this specific problem. And how do we know that? Well, as we were going through our solving technique, we found that negative 10 is less than 36, and that is true all day long. So if you don't believe me, what I want you to do is go ahead and pick any value of x you want and substitute it in. And then you should see that when you simplify it down, the left-hand side will always be less than the right-hand side. Okay? So I'm going to let you go ahead and do that. And if you have any questions, you can always just contact me. So now I want to look at another situation here, okay, where it's kind of like the exact opposite. So let's look at 1/3. Oh, I'm moving too fast. I forgot to graph and write interval notation. You should be yelling at me right now. So, to graph all real numbers, think about it. If you chose the value negative 5 and you substituted it in, the left will always be less than the right. If you decided to choose the number 100, substitute it in, the left will be less than the right. Notice that since these are on both sides of 0, what we're going to do, and I'll use a different color here, we're going to shade the entire line. And that's how we show all real numbers. Okay? And since we shaded our entire line, notice that we shaded that arrow on the left and this arrow on the right. And remember, they stand for negative infinity and positive infinity. Our interval notation will be negative infinity to positive infinity. Okay. Now, let's look at the other situation. Let's look at the other case. We have 1/3 a minus 1/8 a, which is greater than 5/24a plus 3/4. So we're going to do the same exact thing. We're going to solve, we're going to graph, and then we're going to write interval notation. All right? So, step one, if you see fractions, find the LCD so we can eliminate all denominators. So I definitely have fractions, and this will be a nice review for all of us. So what I'm going to do is off to the right here. Actually, you know what? I'm just going to do it directly underneath because I got unlimited space. So here's our LCD technique. I look at every single denominator, and I'm going to write them in numerical order in a column. So I got a 3, a 4, an 8, and then a 24. And I'm going to write the prime factorization of each of these. Now remember, prime factorization means that we're going to be using prime numbers like 2, 3, 5, 7, 11, 13, 17, and so forth. And the word factorization means multiply. So what we're going to be doing is we're going to be taking prime numbers and multiplying them to create the numbers 3, 4, 8, and 24 respectively. Now, I'll go right down a list and just make sure you're watching this because organization matters. So first, 3 is a prime number. So I'm just going to rewrite 3. Now, I'm going to cheat a little bit and give myself some space because I can kind of see some things. Okay? Now, I'm going to go ahead and do 4. So 4, to write the prime factorization of 4, we just create a little factor tree. So 4 is 2 times 2, which are both prime. So I'm going to write 2 times 2, just like that. Okay, now I'm going to do 8. Well, 8 is 2 times 4. And then I can break down the 4 into 2 times 2. So 2 times 2 times 2. And notice I'm giving myself just a little bit of space. And hopefully now you can see why I kind of wrote that 3 off to the right-hand side. In fact, I'm going to write it a little bit more. There we go. And finally, we're going to look at 24. So 2 numbers that multiply to give me 24 are going to be 4 and 6. And then these will break down even further as 2 times 2 and then 2 times 3. So I'm going to write 2 times 2 times 2 times 3. Now, I wrote the prime factorizations of each one of my denominators. Once I do that, I draw a line underneath. I write the letters LCD equals. And then what I will do is I will draw lines straight down the columns. That's why I said organization matters here. And just multiply every single one of these numbers together. So 2 times 2 times 2 times 3 means my LCD is going to be 24. So what do I do with that information? I'm going to take the number 24 and I'm going to multiply it times every single term in my original problem. So let's go ahead and let's do that. So I have 24 times 1 over 3a minus 24 times 1 over 8a, which is going to be greater than 24 times 5 over 24a plus 24 times 3 over 4. Okay? Now from here, we're going to simplify every single denominator. Remember, our goal, and I'm going to draw this real quick, our goal is to reduce every single denominator. We don't want to see any more denominators. So what I'm going to do for us is I'll do this very first one, and I'm really going to show you what's happening. You know what? I'll do it for the very first 2. And then the other ones, I'm just going to go ahead and kind of do it like a shorthand. So here's what's happening in the very first one. We have 24 multiplied by 1 over 3a. All right? Now, what I'm going to do is I'm going to put a 1 underneath this 24. Okay? And watch what happens. That commutative property of multiplication, we learned a long time ago, said order doesn't matter. So what I will do is I'm just going to write 1 times 24 over 1 times 3, and then I'll just put like the letter A right there. Okay? Now, if you look at this, we have 1 over 1. Let me highlight it here for us. 1 over 1. which we know reduces down into the number 1. So I can just go ahead and just cross it out. Now we have 24 divided by 3. 24 divided by 3 is going to be 8, and then you write the letter A next to it. Okay, so when all is said and done, 24 times 1/3 A is 8A. Okay, now I'm going to do the same thing here for this second part. So once again, I'm just going to write 24 over 1 times 1 over 8A. Then I'm going to write it in order. 1 times 24 over 1 times 8 with an A off to the right. Let me write this a little cleaner. I can see that the 1's reduced, so I could just scratch them out, or you can just erase them. And then I'm left here with 24 divided by 8. Well, 24 divided by 8 is 3 with an A to the right of it. So what that means is that this is going to reduce, and this will reduce the same exact way. So what I'm going to do is just erase the board. You can always go back and rewind if you want to, but I'm going to erase the board and just write out what everything is, okay? All right, so I'm back, and here we go. So 24 divided by 3, we establish is going to be 8, so I write 8 times 1A, copy down to minus sign. Next, 24 divided by 8 is going to be 3, so I write 3 times 1A, which is greater than 24 divided by 24 is 1 times 5A. Copy down the plus sign. And then finally, we have 24 divided by 4, which is going to be 6. So we have 6 times 3. So now I'm just going to go ahead and clean this up. 8 times 1 is going to be 8A minus 3A, which is greater than 5A plus 18. Okay? So from here, we're going to look on the left-hand side and combine like terms. Well, we can totally do that. We got 8A minus 3A, which is 5A. On the right-hand side, there's nothing that we can combine, so we just write 5A plus 18. And then finally, we're going to get our variable terms together by subtracting 5A from both sides. Now, what's going to happen here is this. 0 is greater than 18. And once again, notice that our variable canceled itself out. So we need to go ahead and interpret this very last sentence that we have here. Is this a true statement? Okay. Is 0 greater than 18? Well, the answer is absolutely not. So what we say is there is no solution to this problem. And because there's no solution to this inequality, you will have no graph. And because you will not have a graph, you will have no interval notation to concern yourself with. Okay? Now, that's going to conclude this video. So I hope this video made sense, and I hope it clarified a lot of what we've been doing. Okay? So go ahead and check this out. Remember, you can always rewind and everything, and I'll see you in the next video. Bye.